Okay, so this session is on. First thing I want to do is I'm going to create a class. Okay, this is a C++ class. It's called student. This is how we create objects. So this class is a so class is a concept, okay, in object-oriented programming. So you can create an entire class, and this class can have, you know, a whole bunch of what we call member variables. Sometimes they call it instance variable. Okay, does not matter. So these are same thing. And then they have what's called the access qualifiers. So these access qualifiers or modifiers, there are 3 levels. So this is what sets C++ or OOP, object-oriented programming, apart from other languages. And that is the ability to encapsulate informations. Encapsulate informations means hiding them, okay? So if you have stuff, right, underneath public, that means everything inside of that public scope. So basically, there are 3, just think of this entire object, okay? This whole object. This whole object is called student. I'm sorry, class. It's called student. And there are 3 areas, right? 3 areas. So one of them is public, okay? So this public stuff is all going to be here in this area. And the private stuff is all going to be here. And then you have protected stuff, okay? So let me just explain what they are. So public basically says, you know, it's like the clothes you wear on the outside. Like people see it, right? So that's public. So let's just say this class student is you, right? Stuff that is private, you know, what you have, your private stuff, no one's going to see it. And you're not going to, you know, this means that you're not, you know, intentionally exposing yourself to other people, letting other people see the private stuff you have. And so private means private, okay? In the context C++, nobody sees it unless you so choose to reveal, you know, these private informations out to other people, but typically you don't. Protected means only your parents or people who are in your family can see it. You see what I'm saying? So protected is kind of in that sense. If you're taking Java right now, protected means that in addition to inheritance visibility, you also have what's called package capability visibility. So it's a little complicated, but I don't want to get too much into it. So remember that this students, okay, class has 3 areas: and public, private, protected. Okay, so I'm just going to make it public. Okay, so I don't want to confuse you guys. So these are, you know, access modifiers. So let's just leave it there, right? I just want to make use of my public here. So the first thing you do is what's called constructor. So what is a constructor? Constructor is a point of access to create this student. So think of a class student as a construction blueprint, okay? So at runtime, you can call upon this blueprint to construct a house, right? And the entry point for constructing that instance, that object, or that house is your constructor, okay? So in the beginning, you have this thing called constructor. Now, this one is default. Default means that this student, notice that this student doesn't really have any attribute. It's not even a function, right, at this point. It looks like a lot like a function, but it's not, because it's not returning anything, right? There's nothing returning. And it's basically empty in here. There's nothing in there. So that's totally fine. We can leave it as this, right? And then you can also have another constructor that is user-defined, right? This is a user-defined. User-defined means that you can, instead of leaving, you know, this entire argument area is empty, you can actually insert something of your choice. So you can say, hey, this student, I'm going to enter my name right in there, and so on and so forth. And for as far as the member variable is concerned, you can create a C++ string called name. So this student is going to have a name. And this name is private to that student. So in other words, this one is going to be private, okay? This is the deviation from C. C, everything is public, okay? So if you create a class in C, it's called struct. In C, a class is called struct, okay? Struct. So let me just be absolutely clear. So C++ class, okay? So what we have here is C++ class. We're not talking about C here. I have this thing here, name equals name. Okay, let's take a look at what's going on here. So this, okay, THIS. Now, if you took Java before, you know what I'm talking about here. So this refers to the instance of the students. So as a matter of fact, every class in C++, this is true in Java as well, except Java does not use pointer. Java uses references. C++ has this pointer, THIS. This is pointing to itself. So this is a pointer. Remember what a pointer is, right? This is a pointer to an instance of a student at runtime. So at runtime, this student is going to be a three-dimensional object, right? It's going to be flowing in memory. And this memory is going to have, you know, the public area, private area, and also protective area. And so THIS is a pointer, right? So pointer is a variable that stores the memory address of this student right here. So this student's at runtime. Okay, this student, I should say this student object. Okay, so at runtime, you're not going to see a class. Everything is going to be an object. So this object is going to have memory space. So this memory space is going to have, I don't know, maybe, you know, 0 times FA2. So this, right, is a pointer that has this value in there. So this value is going to be the value of this, okay? So THIS that you can use for any objects. Now, if this is a pointer, in order to get this pointer's attribute, in this case, this pointer is student, right? And name is this, right? Student's member variable. Then you would need to use this pointer. So this arrow here represents pointer, okay? This is a pointer redirections to its member variable. So what you have here is basically the two constructors here. But what I want to do is, what we want to do is, what I want to get, you guys know what a getter and setter is? Heard about it? So getter and setter is a wrapper function methods that wraps this internal stuff that, which is name, right? You do not access name directly. You have to actually make a method to call it or to set it. So the caller is what we call getter. This is accessor. Okay. Getter accessor method, and this one is setter accessor method. Create get names, right? So I can invoke this student's objects, get name to get the name out of the objects, right? So that's what I want. So as a name imply, this method has to return a string because I'm getting a name, right? You can say get name, right? This get name doesn't take anything because you're just getting the name, right? You can actually return name right here. This name references this name. It's the same thing. Or you can do this name. Doesn't matter, okay? So I'm getting rid of this in this fashion. I can't here. Why? Well, because if I do this, wait, is this name the one on the right side or left side, right? So this is the reason why you put this here. This means this student's, right, name, okay? But this is a pointer, so you have to use the arrow. If this is not a pointer, but a regular reference, then you use dot, right? This dot name. But so in Java, you actually dot name, okay? This dot name. The getter method and the setter method is my void. The setter doesn't return anything, right? I just want to set my name, and this is my string name, right? But here comes the interesting part because I can't just say name equal name, right? Because what I want is I want this name, okay, which is coming from outside, right? To have this to set the value of my internal name here, right? My student name is going to be modified based on the name that passed in. So since I'm using name and name, right? To avoid confusion, I should do this, okay? I've got two constructors, one setter, one getter, in a private member variable, or sometimes we call them instance variables. In instance variable is a Java term. In C++, we like to call them member variables. But cool. So this isn't my student. My entire class is now defined. Since I'm not using modifier, right? So let me just get rid of it. Okay. So let's just keep it really, really simple. Sometimes I do not feel like having this defined in there. So I just want declaration. Okay. Declaration is different than definition. Okay. So this one is a definition. I already defined it. Okay. So I already defined this get name, but I want to take the set name outside of the class. You can totally do that. The reason why this is the case is because lots of times your methods may have 100 lines of code, right? You don't want to further expand, even though you can, right? This class for 23 pages. That's not a good idea. Like no programmer would do that, right? So they'll take it outside and said set name, string name, okay? But here comes the problem. How do I know this? If I do it this way, then this set name is outside of my main. So this looks like this set name is just a function that main can call it, right? But that doesn't make any sense, right? Because set name is part of students, right? So what I want to do is to make sure that people understand, the set name is part of the student. So you would actually have this thing called student : This is class scope. This thing is class scope. What class are we talking about? Students, okay? So this means that this set name is actually coming from within that student class, which is here, right? So this thing is a decoration now, okay? Inside, but here on the outside is what we call definition. So this one is students method set name definition, okay? This is declaration. This is part of your student. So you can still use this, even though you're outside of the class. So this is, the way to set it. Let me run this. You always want to do that because if this thing doesn't, this is a class definition, so you have to have a semicolon. Okay, so everything here works, okay? Because you see exit code, which means main was run and this entire thing was compiled and there was no error. What I want to do is I wanted to statically allocate, right? A student object, okay? So student object, this is capital S, right? So how do you do that? You can say student, and just say this is static S, okay? Because I'm going to do this dynamically as well. This is static memory allocation, this part right here. So this means at runtime, okay, this is your memory cloud, right? So this entire, there's a memory cloud. This is a stack memory right here. This is stack memory. And this is heap memory. So stack memory, it's actually in here, right? And everything else is heap, okay? Everything else is heap. So this static S, it's actually coming from here, okay? It's actually coming from this stack memory right here. So this is what we meant by statically allocating a student memory. What we can do is we can see out. Well, let's see if this works, right? So what we want to do is static S dot name. And the reason why you use dot and not the arrow before is because static S is statically allocated. So you can print this out, but the problem is name is not defined, right? So there's, right? So we kind of want to pass my name into it. So you would use the constructor. So in this case, this goes through this static underscore S is actually using a default constructor, and there's nothing about this setting about name. So this is not good. What I want to do is I want to pass my name, Joseph, into it. Okay. So what's going to happen is this static S, right? This Joseph is going to invoke this user-defined constructor right here. Okay. So remember what I meant by constructor, right? Constructor is your entry point to creating the objects. So every object has to go through a construction phase. Construction phase calls the constructor, and you are invoking this user-defined constructor that receives a string, okay, into it. If I do static name, I should be getting a name out of it, right? So if you just do get name, it will get the name and return it there, right? So this is one way to access someone else's memory variables. And let's do a dynamic memory allocation, okay? Dynamic memory allocation means that in this case, I'm going to say this is just to differentiate this dynamic student object versus the statically allocated one. I'm just going to call it dynamic object. So this is student start, right? So you do this, right? Okay, so in this case, I'm still going to be using the user-defined. This is the user-defined constructor. I want to pass a name to it. So in this case, I can also pass a name. I'm going to call Joe, right? So this dynamic object is going to have the name of Joe. The static one is going to have a name of Joseph. Okay, that's the difference here. Do C out, right? I can do dynamic S, but now dynamic S is a pointer, right? So I have to use the arrow. Okay, so I have to use the arrow operators and not dot, right? In this case, static one is dot. Arrow is dynamic. Okay, so arrow is applied to a pointer. So dynamic S is a pointer. So I want to do get name. Okay. So the only difference between a static one and dynamic one is one uses a dot and the other one uses the arrow, right? And you should be able to print this out. Let's see if this works. Ran it or didn't. Okay, so you can see Joe's printed, right? So the second version is actually the dynamic version. The first one is the static version. Now, I have a memory leak here. You can see when I return 0, I did not release the memory. So what you need to do, even though it's not shown here, it's leaking memory. Okay, so I'm wreaking havoc on someone else's machine right now. If I do this more, a lot of times, I can basically crash someone else's machine. You got to delete this, okay? So delete dynamic as releases the memory back into that machine. I can run it again. It's going to be the same effect. This time I have no leak. Okay. The other thing I can do is I can get rid of this. And I said, hey, I don't want to use my user-defined constructor. I want to use a static one. Okay. So the default one says, hey, I don't want anything. So this will still compile. But the problem is this one does not give me any name, right? So the way I can do that is I can set the name at runtime, right? Set the name. And definition is already done here, right? So you guys know what this is. So what I want to do, since now there's no name, so I want to do need to set name, right? Dynamic s set name, right? And I want to give it a name called Joey this time, okay? Joey. So I can keep the CL again because now this object at instantiation does not know its name, but later on I give it, okay? And then I want to get it, and then I deallocate this at the end. So let's take a look at this. Oh, no, I'm sorry. This is a pointer. Always remember that. Cool, now you have Joey. So this is a quick illustration of student's object and how you make use of it and what this class means, as well as what a member variable is in the public scope, constructors. So I covered a lot of that stuff.